Okay, so in this video, we're going to continue on in Chapter 5, and we are going to take a look at our number 9 learning objective here. We're going to determine what a molecular compound is, how it's different from an ionic compound, and then by the end of this video, you should be able to name them and write their chemical formulas as well. So let's check it out. So what is a molecular compound? So molecular compounds are made of all nonmetals, okay? So when we were looking before, we were looking for metal cations to indicate that we had an ionic compound. However, if you see a chemical formula that has no metal, so it has no metal cation, and it doesn't have that ammonium ion, okay? So you see a metal without the ammonium ion, or you see a compound without the ammonium ion in it, it's a molecular compound. So it's basically anything except for metals and ammonium. Not bad, pretty easy to identify. So what's interesting about molecular compounds is in comparison to our ill-defined molecules, our kind of crystalline solids of ionic compounds, we actually do have well-defined molecules. So these are going to be more well-defined molecules, okay? So we know that we can identify it by saying that we don't have ammonium or we don't have a metal, but these are what we call the well-defined molecules. Ionic compounds were ill-defined. We couldn't tell which sodium went with which chloride in our picture. However, in well-defined molecules, we can actually tell which atom is connected to which, and we can see separate molecules from each other. So when we're talking about those formula units of ionic compounds, we're calling them formula units because we kind of can't separate out just exactly one sodium chloride. However, here we have well-defined molecules. I could pull one of these CO2 molecules out and know that I had exactly one CO2 and I had one carbon attached to 2 oxygens. So when we're using a chemical formula, really we're saying that this kind of atom is bonded to these other kinds of atoms. There's specific little units that are repeated over and over again. So again, that's why we use formula unit for ionic compound and we say chemical formula for molecular compounds. That's the distinction there. A chemical formula is really representing those individual molecule units in a molecular compound. So again, looking at our CO2 over here that we can see on the screen, when we look at the name or we look at the chemical formula or we look at our space filling model, we don't see a metal and we don't see the ammonium ion. So that means that we have a nonmetal, or we have a molecular compound. Of course, it's made of nonmetals. So that means we have a molecular compound. And so what it really looks like when these things are hanging out, regardless of whether they are solids or liquids or gases, what have you. The idea here is that we've got these individual molecules interacting with each other. So these individual molecules are all interacting with each other as specific base units. So they're going to always be CO2 and stuff like that. So these are, again, well-defined molecules. You can tell that this carbon goes with these 2 oxygens. This carbon goes with these 2 oxygens. That's really the big distinction between molecular and ionic compounds, is this concept of a well-defined molecule, okay? So, what are these molecules? How are these molecules made? So, these molecules are made through covalent bonding, okay? So, we talked a little bit about how it was ionic bonding because really we were just thinking about the fact that we had these ions that were positively and negatively positively and negatively charged so that those were attracted to each other. So if I have a positively and negatively charged ion, they're going to hang out together, they're going to attract. We just kind of call those ionic bonds. However, really what a chemical bond is a covalent bond is what we would call it. We would call it a covalent bond. So molecules are covalently bonded together. This is really what we traditionally think of as a chemical bond. So whatever you're thinking of in your head as a chemical bond, I guarantee you're probably thinking of a covalent bond. So this is where the electrons are actually shared between the atoms. So we talked about in ionic compounds how if we have an anion and a cation, the cation can transfer some of its electrons to the anion. So we have this transference of electrons. So we have these distinct ions. Here, we no longer have this distinction. What we have is that these electrons are shared between the atoms through an overlapping electron cloud. So that would be what the stick represents on the ball and stick model. It represents that the electrons are being shared and passed back and forth between those 2 atoms. We'll talk about this a lot more as we start to talk about molecular shape and things like that in Unit 3. However, for right now, you should just know that that's kind of how they're held together, is through these covalent bonds. And what's really cool about covalent bonds is they're really strong. There's one that they're going to be one of the strongest things we're going to just kind of come across this semester. So they're much stronger than ionic bonds. They're like, in my head, I really want to say it's the strongest force we're going to come across this semester. Like, they are stinking held together and held together well. Different chemical bonds are different strengths, of course, and we'll talk about that as well. However, all the covalent bonds we're going to come across are going to be much stronger than any ionic bond that you could choose. So it's much harder to actually pull apart that carbon in those two oxygens than it is to separate a sodium ion from a chloride ion, okay? So it takes a lot more energy to actually break apart a molecular compound, to take those individual atoms apart from each other, than it does to just separate ions that are hanging out because they're just positively and negatively attracted to each other. So we could find something it's more attracted to instead. So it's pretty easy to pull off those ions. However, with a molecular compound, it's so much harder to actually pull those atoms apart from each other that actually make up something like CO2. So covalent bonds really are like the real driving force that holds molecules together. So now that we know what a molecular compound is, we need to spend just a little bit of time talking about how we name them. So again, molecular compounds, when you look at a chemical formula, if it only contains nonmetals, not ammonium, you should follow the naming rules for molecular compounds. So this is going to be no metal ion, no ammonium ion. If you see that, you have a molecular compound. In the next video, we're going to talk just a little bit about a special case of acids, so you should know how to name specifically acids. However, the rules we're going to talk about in this video would apply to any molecular compound that we're going to come across that is not an acid. Okay, so again, we'll talk about acids, we'll talk about how they're different, but these naming rules apply to molecular compounds that are not acids. So for right now, we're only going to look at molecular compounds with two different types of elements in them. So we're just going to have a binary, a first element and a second element. We're going to talk about more complex naming schemes of nonmetals when we get to organic chemistry later. We'll talk a little bit more. I'm sure when we get to acids and bases too, we'll get a little deeper into acids as well. So know that there's a bit more coming up that, we'll be able to name things like C6H12O6, which is sugar. We'll know that we can look at that. We'll figure out how to name it sugar or name it its specific chemical name. But again, for right now, we're just going to know how to name molecular compounds with two different types of elements in them. So really, more than anything here, the kind of big preview that we have is you just have to make sure your atoms are in the correct order. So most of the time, you can kind of go from like the bottom left of the periodic table to the upper right-hand corner, and that's kind of going to be the order of the nonmetals is going from the bottom left to the upper right. There's a specific reason that this happens, and we will talk about it just a little bit later. But you need to know that when you list an order, or when you're listing your nonmetals when you are listing your nonmetals, when you're naming a molecular compound, or you're writing the chemical formula of a molecular compound, your atoms need to go in this order. So mostly it's kind of, again, that bottom left to the upper right-hand corner, except for, who, our favorite hydrogen is out of order, thrown in the middle somewhere. So as expected, hydrogen's doing something different, but other than that, everything should be named in this order for the most part. So what are some actual steps that we can take to name molecular compounds? So, I got big. There we go. Okay, so what are some actual steps that we can do to name molecular compounds if I had to put it into words? So these are going to be our steps to follow. So it's pretty straightforward. It's much easier than the ionic compounds, I promise. So the first thing we need to do is determine how many of the first kind of atom you have. And how do we determine how many copies of one kind of atom are in a compound? The subscript. So the first thing we're going to do is we're going to look at the first kind of atom, and we're going to determine what the subscript is. That tells us the number of the first kind of atom we have. So we're going to count how many of the first kind of atom we have. from there, we write the elemental name of the atom, so that name on the periodic table, with the correct prefix for the number of atoms that we have, okay? So you can see my list of Greek prefixes right here on the side. So we're going to use the Greek prefixes to name these. So if I have one atom, I have mono. If I have two atoms, I have di. I have three atoms, I have tri. So on and so forth on through deca. So you may have seen these Greek prefixes when you were naming shapes in like geometry or something like that, like a pentagon, a hexagon, an octagon. So you may be familiar with these prefixes. You may have seen them before, but these are the Greek prefixes. So once you look at your first kind of atom and you've looked at the subscript, you need to give it the prefix that is appropriate for the subscript, for the number of atoms. So you take the elemental name of the atom and you attach this prefix to the front of it, okay? So the only caveat here is if we're looking at the first element, we're looking at the first kind of atom, we do not write the prefix mono for the first atom, okay? That's like the most tricky part of all of this. So you look at the first atom, you attach a prefix, you just don't have to use mono if it's just one. We also need to look at the second atom. So deal with the first atom first, deal with the second atom second. So in this case, you need to determine how many of the second kind of atom you have. So this is given as the subscript again, same thing. And then you attach your prefix to the ion name in this case. So we're going to use the ion name with that IDE ending. So our first atom is going to get the elemental name. Our second atom gets the ion ending, the IDE ending. So you use mono on the second ending with the IDE ending. So if you have one atom, you would say mono if it's the second kind of atom, and then you add the IDE ending. So you use that anion name. So in summary, you use prefixes to say how many of each kind of atom you have, and you use the elemental name for the first atom, you use the ion name for the second atom. So all we're doing is we're writing how many numbers of atoms we have. Much easier than having to determine the charge on a metal cation. So non-metals are a bit easier to deal with in my opinion. So let's do some. All right, so let's work through some examples of how to actually name these compounds. So we talked about the rules. How do we actually do it? So, all right, don't be funny with me. I asked for the real name for H2O for the reason because, of course, we could say water. That's the everyday name that we use. That is a name for H2O. However, how do we actually name it if we follow our rules? So we look at this. We see that this is a compound that does not have any, that does not have a metal. It does not have an ammonium ion. It's a molecular compound, so let's follow the molecular compound naming rules. So remember, all we're doing is looking to the subscripts to name our elements with the prefixes. So if I have two hydrogen atoms, 2 gets the prefix di, so I have dihydrogen, and oxygen does not have a subscript, so that means it has a subscript of 1, so that would be monoxide. Remember, it takes the anion name for the second element, so dihydrogen monoxide. That's the actual real name for water. And if I haven't told this anecdote before, and if I have, I apologize, lots of times local city governments will go crazy banning chemicals. They're like, no chemicals in our town. And then they ban dihydrogen monoxide. To ban dihydrogen monoxide for absolutely no reason. They banned water. I don't know how they're going to stay alive because you can't live with water for that long, or without water for that long. So don't ban dihydrogen monoxide. When you see a chemical name written like a molecular compound or like an ionic compound or an acid or organic compounds, as we talk about later, it doesn't mean it's scary. You just have to know what it means and understand it to know dihydrogen monoxide just means 2 hydrogens, 1 oxygen, H2O, water. So again, dihydrogen monoxide, 2 hydrogen atoms. Hydrogen is the one that comes first, so it gets dihydrogen, it gets the elemental name. And oxygen is the one that comes second, so we use the ion name for the element that comes second, and we say mono because there's one, dihydrogen monoxide. Okay? Okay, so let's go ahead and do the second example on our screen, BRF5. So I check out the chemical formula that I see, and BRF5 does not have a metal in it, and it does not have the ammonium ion. I follow my molecular compound naming schemes that I see. So first things first, I look at the first one, then I look at the second one. So I look at the first atom that is bromine. I look at it, I determine how many copies of the bromine atom I have. Well, it has a subscript, or it has no subscript, so therefore has a subscript of 1. So I have 1 bromine. Because it's the first element, I give it that elemental name. Bromine, not bromide, bromine. And so the one thing we have to remember here is, we're looking for the prefix to attach. However, if the first element only has 1 atom, we don't write mono. So this wouldn't be mono bromine something. It would just be broming something. We don't have that mono prefix. So the first atom is named bromine because it would have the mono prefix, but it doesn't because it's the first one. And it takes the elemental name, not the ion name. So bromine. We have F5 as our second atom. So F5 sounds like a tornado. So F5 is going to be 5 fluorine atoms. So I think about it. 5 means I have the prefix penta, so I know I'm going to attach the prefix penta to my name. And then from there, I'm thinking about the fact that fluorine is the second atom, so it's going to get the ion name. So this would be pentafluoride. So if I'm looking at the compound there, I would call that bromine pentafluoride. So bromine pentafluoride. There's 1 bromine atom. It's first, so it gets the elemental name. Technically, it would have the prefix mono, but we don't write it on the first one, so we just write bromine. And then there are 5 fluorine atoms, so it gets the ion name with the prefix penta because it's the second element, pentafluoride. Bromine pentafluoride. And so our last one here, we have just a carbon and an oxygen. How would we name a chemical molecule that has a carbon and an oxygen in it? Okay, so I'm thinking about this. I look at my first atom. I determine that there is only 1 carbon atom. So I have a subscript of 1, but I don't write it. I don't see it there on the screen. So that would be 1 carbon atom. However, I remember it's the very first atom. So therefore, it does not take the ion name, it takes the elemental name, and because I only have 1 of the first atom, I do not attach the mono prefix. So this would just be carbon something. So carbon something, I get the elemental name with no prefix because I only have 1 carbon. For the oxygen, I look at the oxygen, I see that it has no subscript, so therefore it basically has a subscript of 1. So your oxygen would be a prefix of mono. However, we have to be careful that it's the second element, so therefore it gets the ion name. So I have monoxide. Carbon monoxide. Okay, so this is the nasty gas that can hurt you if you run your car in a garage or run space heaters like that. They've had problems in Texas because of all of the cold that's happening right now there, that people are running their ovens or something like that. And some people are getting carbon monoxide poisonings because of this. So you never want to run an oven for heat in your house, and this is why, because it may introduce carbon monoxide in. So we named our carbon monoxide. It's just a C and an O. So we have carbon monoxide. This is going to be 1 carbon atom. It comes first, so it gets the elemental name. We would have a prefix of mono, but we don't write it on the first one, so we have carbon. We have oxygen. This is an oxygen, or we only have 1 oxygen atom. Again, no subscript, so therefore we have the ion name with the prefix mono, monoxide. So those are some examples for how to name molecular compounds. I've left you with some practice problems here as well with their explanations, so please check those out. Please try to work on naming these ionic compounds. And now we're going to learn how to write the chemical formula. Okay, so we just looked at going from the chemical formula to the name. So now let's take the name and figure out the chemical formula. So if you haven't figured it out already, this is going to be extremely straightforward. So we know exactly how many of each we have. We don't have to figure out all of the subscripts. You look to the prefix to determine the subscript because we've explicitly given you how many of each atom are there in the name. Okay, so let's talk about some steps just to lay it out a little bit more. So you look at the first atom you have, you determine how many of that atom you have through the prefix. So you look at the prefix, and then that becomes the subscript. So the prefix basically becomes the subscript. And again, if the first atom has no prefix, we assume it to be 1. So once we know what the subscript is supposed to be, we write the chemical symbol with the correct subscript. We do the same thing for the second atom. We look at the prefix on the second atom to determine what the subscript's going to be. Then you write the chemical symbol with the correct subscript. I told you, it's way easier than when we do ionic compounds. So we use the prefixes to determine the subscripts with molecular compounds. Let's do some examples. So let's write the chemical formula of dibromine monoxide. So I look at my first one, I see that it's bromine with the di prefix. Di means 2, so I have Br2. I see I have monoxide. Monoxide is oxygen. So I say I've got mono oxygen, so I've got 1 oxygen, so I've got O, and we wouldn't write a 1 for a subscript ever, right? So we would have Br2O, dibromine monoxide, Br2O. Super straightforward here. So if we look at number 2 on your screen, we see boron trichloride. So if we have boron trichloride, we're going to look to the first one. We see that it does not have a prefix, so it means mono. So I have 1 boron if I just see the elemental name written. So 1 boron, just a capital B. And then I have trichloride. Well, I see chloride, so that means I've got chlorine. I see tri, that means I have 3, so I've got Cl3. Pretty easy. So BCl3 is going to be our name here, or our chemical formula. BCl3, boron trichloride. So boron gets a subscript of 1 from that missing mono prefix, and chlorine gets a subscript of 3 from that tri prefix. One last one, then I'll leave you to your own devices practicing, and we'll move on to acids. So let's write the chemical formula of trinitrogen tetrabromide. Okay, so trinitrogen tetrabromide. So if I'm looking at trinitrogen, I see I have nitrogen as my element. I have tri as my prefix, so I have N3. Tri means 3, nitrogen N, N3. And then I have tetrabromide. I have bromide, which is bromine. I have tetra, which is 4. So I've got Br4. Tetrabromide, Br4. So I have N3, Br4 in this case. So trinitrogen tetrabromide, N3, Br4. Nitrogen gets the subscript of 3 from that tri prefix, and bromine gets a subscript of 4 from the tetra prefix. So I've got some more examples for you here to work through. Please work through these examples. Please let me know if you have any questions. I highly recommend working through these and then double checking your answers in the PowerPoint slides there. So let me know if you need any help, but that is how we name molecular compounds and then write their chemical formulas as well.